This region between Florida and the Bahamas is a famous place for studying various marine life. However, there's a mysterious phenomenon that happens here each year, the reasons for which scientists have yet to figure out. At times, people can see these white clouds appearing on the surface of the water. In technical terms, this occurrence is called a whiting event, the deepest part of the ocean these days. But there's a lot we still don't know about the depths of our planet's waters. One such intriguing fact is pretty common among aquatic creatures, with 3/4 of all underwater life being capable of this. Bioluminescence can be found anywhere, from the surface to deep within the sea, even as deep as 2.5 miles. These creatures use light for various purposes, for example, for communicating with their own species, attracting prey, or scaring predators away. The science behind bioluminescence involves the use of 3 chemicals: luciferin, luciferase, and oxygen. This process was first discovered by a French biologist named Raphael Dubois in 1887. If you want to know the difference between real bioluminescence and artificially created light, look for neon blue, green, or red sparkles spread over a large area in the ocean. This can create a captivating and magical effect, much like glitter or stars in the sky. And it's often because of squid, small crustaceans, and algae found in shallow waters. Have you ever heard a strange noise in the middle of the night? Now imagine that, but in the middle of the ocean. There are a few bizarre sounds that have been heard and recorded, like the bloop and Julia. Most experts think they come from big things, like icebergs scraping the ocean floor. But what if that's not the answer? In 1997, scientists were listening to underwater volcano noises in the Pacific using underwater microphones called hydrophones. One day, they heard a very loud and strange sound that was different from anything they had heard before. They called the sound the bloop. They couldn't figure out what was making this sound and thought it could be coming from a secret underwater mission, ship engines, whales, or an unknown sea creature. Years went by, and researchers continued to try and find the source of the bloop by putting hydrophones closer to Antarctica. In 2005, they finally discovered that the bloop was caused by icebergs breaking off glaciers and falling into the ocean. This phenomenon is called an icequake. With Earth's overall temperature rising each year, icequakes are happening more often, causing glaciers to crack and melt into the ocean. Then, on March 1st, 1999, a loud noise was again heard underwater in the Pacific. The U.S. National Oceanic and Atmospheric Administration thought it was probably an iceberg breaking too. But the sound was different. This led some people to think the noise came from a sea monster named Julia. Some thought it was a new unknown species, while others believed it was a known creature, like a whale or a giant squid. Some even thought it could be a prehistoric animal. To this day, there's no proof that any of these theories are true. Then there's a story of an island that was swallowed whole by the ocean. It was called Bermeja, and it was a tiny and uninhabited island located at the northwest of the Yucatan Peninsula. Just a century ago, it was known to be located in the Gulf of Mexico, but now it's vanished, leaving everyone puzzled. In the past, Bermeja was frequently depicted on maps created by Spanish explorers during the 16th and 17th centuries. Although its location and name varied slightly, no one ever doubted it existed. However, starting from the 18th century, the island's presence on maps started to fade until it finally disappeared completely. So, nice descriptions of Bermeja's existence. They firmly believe the island did exist, but in a different location.
The surface of this river looks as if it's covered with fish scales. Is it a giant water dragon or some other ancient monster? Not really. The explanation is much more boring, but surprising at the same time. Now let's start from the very beginning. This is the Shantung River in China, and this is Hangzhou Bay, its estuary, which is the tidal mouth of a river, where the tide meets the stream itself. Now this area is home to the world's largest tidal bores. A tidal bore is a strong tide that pushes up the river against the current. In the Shantung River, such tidal bores can reach a whopping 29 feet. The area regularly sees trains of large waves moving upstream. But in 2021, during a scientific expedition, experts discovered a marvelous natural phenomenon unique to this area. Sometimes, the tide comes in swirling waves. That's the famous fish scale tide. Thing is, this region has rotating currents, which means that the tide doesn't just move inland and then simply reverses its direction. Instead, a rotating current easily changes direction without changing its speed. This makes the Shantung River perfect for winding up with groups of waves crashing into one another at oblique angles, which is like a cross sea. Let's speak about this phenomenon now. These four-sided wave patterns in the ocean look mesmerizing, as if the ocean deities decided to play a round of giant chess. But what you observe is the phenomenon known as square waves. They're often called cross-sea and grid waves too. The thing is, most waves reach the shore and break parallel to the coastline. But in some regions of the world, these waves create a chessboard-like pattern on the surface of the water. When you look at these waves from above, you might think there's an underwater grid forming square-shaped ripples. But square waves aren't caused by anything taking place beneath the surface of the water. They're the result of the way the water moves. Weather patterns in certain regions make waves form at different angles. When two opposing swells crash, we've got this unique pattern on our hands. However beautiful and unusual this natural phenomenon is, it's also extremely dangerous. If you spot square waves while swimming, get out of the water immediately. Square waves usually come hand in hand with rip currents, incredibly strong currents flowing seaward from the shore. Plus, square waves can reach 10 feet in height, and that's not something even an experienced swimmer can deal with. So, we're done with the seas for the moment and are moving to the largest active volcano in Europe. It's Etna, and it continues to amaze us with jaw-dropping smoke ring shows. But wait, people live there. Isn't it time to evacuate them? The volcano looks like it's about to go off. Well, let's calm down. There's no need to fuss. Experts assure us that the production of such rings doesn't mean that a big eruption is on the way. These white smoke rings are made of water vapor and are generated by bursts of gas bubbles inside a narrow duct over a magma chamber. Etna was even nicknamed the Lady of the Ring, and currently the volcano is breaking its own records. For example, in the year 2000, the volcano produced around 5,000 such smoke rings. According to researchers, no other volcano on Earth produces as many volcanic vortex rings as Etna. Southeast Crater is especially active. It emits countless beautiful vapor rings. Now, don't look away from the sky. You might witness something like what the residents of New Jersey saw recently. A massive fireball lit up the sky in the Garden State and surrounding areas. A meteor falling to the ground looked like a bright streak of light. And the folks of several New Jersey towns, as well as some parts of New York, Pennsylvania, and Connecticut, reported this show to the American Meteor Society. Security camera footage posted online by some witnesses of this awesome phenomenon showed the flash dash across the sky within a couple of seconds at 3:43 a.m. Another unbelievable phenomenon captured recently is one of the rarest in the world and almost impossible to see with the unaided eye. A West Australian photographer was shooting a wet season thunderstorm just outside of Derby when he managed to film on camera a few red sprites. He said later that they were gone in the blink of an eye. He described red sprites as huge, feathery tendrils of purple and red and specks of bright red. Red sprites are massive electrical discharges that take different shapes and look like reddish-orange flashes. They last for just fractions of a second and occur after super-strong lightning strokes. Even though they're usually caused by the lightning discharges between a thundercloud and the ground, sprites soar up into the air, up to 60 miles. Interestingly, this phenomenon had been dismissed and considered to be fiction for decades, until scientists finally caught it on film. Since that time, red sprites have been recorded regularly. Catatumbo lightning is the world's longest lightning storm. The heart of the storm, which repeats every year, is over the mouth of the Catatumbo River, where it empties into Lake Maracaibo in Venezuela. This storm towers higher than a regular one. Catatumbo lightning occurs for 140 to 160 nights a year, lasts for 9 hours a day, and produces 16 to 40 lightning flashes per minute. Maybe you've heard of how they say lightning doesn't strike the same place twice? Well, Catatumbo doesn't seem to know about this rule. Or at least, it doesn't prevent storm clouds from gathering in the very same place year after year. A fellow hill walking in the UK has captured amazing shots of a weather phenomenon that was called an angel in the sky. So look at it. This scene was captured with a Canon 5D Mark IV camera. The silhouette, though, isn't some non-material thing. It's just the shadow of the photographer at the center of a circular rainbow. Mesmerized, the photographer took a few more photos and continued walking. Such an effect is produced when an observer stands above the upper surface of a cloud. It can also be a mountain or some other high ground, and the sun should be shining from behind their back. When the observer sees their shadow, the light is reflected in such a way that a bizarre circular glory appears around the point directly opposite the sun. Another cool sky phenomenon was witnessed in Auckland. Look at this. What does it remind you of? I bet you think it looks like a spaceship from a different civilization, but it's just a rare meteorological phenomenon. Everyone who saw the circular cloud formation said it looked like a hole in the cloud cover, and some also added that a small rainbow was visible inside. This phenomenon is known as a fall streak hole and a punch hole cloud. Such a formation is quite rare. Even experts have seen it just a few times throughout their careers. What happens here is some sort of atmospheric disturbance within supercooled water, the disturbance being an airplane or something similar. As a result, the supercooled water rapidly turns into ice crystals. Since the crystals are heavier than the surrounding cloud, they fall out, leaving a hole behind. The process happens high up in the atmosphere and is quick. It takes only minutes or so. Well, let's get back to the ground and examine the phenomenon people in the US can witness. It's an extremely rare one. Nothing similar has happened like this since 1803. What is it? Billions of cicadas from two different broods are merging together from the underground after more than 200 years. All these loud singing insects belong to two distinct families of periodical cicadas. One group emerges to the surface every 13 years, and the other every 17 years. It's a rare occurrence when the cycles of both groups align. This year, this once-in-a-lifetime event is taking place since two groups with different cycles are emerging at the same time. These broods are known as Brood 13 and Brood 19. They have been seen and heard across the southern U.S. and as far north as Illinois. So in Westbrook, Maine, people saw an enormous ice disk in January 2019. This disk was like a wintry carousel. It was spinning away in the Penobscot River. Residents called it everything from an icy lazy Susan to a frozen spinning wheel. It was estimated to be around 300 feet wide, which made it one of the biggest ice disks ever seen. Weirdly, the spinning ice disk notion isn't new. They've shown up in places like Russia and Washington before. They were almost always a perfect circle. So why do they happen? Well, some scientists in 1997 thought it was because river water created a whirlpool effect around a chunk of ice, smoothing it out to be perfectly circular. Yet, in 2016, other scientists claimed that river currents helped these disks get started, but temperature changes kept them twirling. Warmer water makes the ice melt and sink, creating a vortex that keeps the disk spinning. The warmer the water, the faster it spins. 30s. These luminous wonders show up in all sorts of colors and shapes. Sometimes they flicker, and other times they just chill in the air. The Hessdalen lights can show up 10 to 20 times a week. Interestingly, nobody has a clue about what exactly they are. The efforts to understand these lights include Project Hessdalen, started in 1983, and later projects like the Triangle Project. Despite ongoing research, there's no consensus on the origin of the lights. Some suggested explanations include misperception of celestial bodies, aircraft, or mirages. One theory ties the lights to airborne dust from mining, while another mentions plasma, formed by ionized air and dust during radon decay. Okay. Ringing rocks is a cool geological thing you probably didn't know about, and it's our next stop on the Mysterious Natural Phenomena Tour. You can find them in Bucks County in the U.S. If you give these rocks a hit with a hammer or another rock, they start ringing. Scientists have been studying them, but the mystery remains. There are different hypotheses about this one too. Things like the size and shape of the boulders and how they're stacked can affect the sounds they make. But that alone doesn't give them the ability to ring. Even though the sound is often described as metallic, it's likely because of the rock's density and internal stress, not just its iron content. A scientific experiment from the 1960s suggested that the ringing ability came from some internal stress, not external weathering. The live rocks, found in the middle of boulder fields, showed expansion or relaxation after being cut, indicating internal elastic stresses. A slow weathering rate in dry fields could cause these stresses. The relic stress theory suggests that these boulders act like guitar strings. A de-stressed boulder gives a dull thud, but a stressed one resonates at different frequencies. The boulders can still ring when removed from their fields, leading to myths about stealing them. Most fields are now cleared of smaller ringers, and breaking large boulders stops the ringing. Large equipment is needed to move the remaining small ringers, weighing over a ton. Now let's talk about the Naga fireballs. They only show up along the Mekong River in Asia. These picky fireballs hang out in just a 155-mile stretch of the river. The reddish glowing balls rise naturally from the water into the air. Their scope ranges from small particles to the size of a basketball. The reported number of fireballs varies, from tens to thousands per night. They can be spotted all year round, but they seem to go wild during the full moon in late autumn. Why? Well, that's just another one of their little mysteries. Some have tried to explain the phenomenon scientifically. One theory suggests that flammable phosphine gas from the marshy environment could be the cause. However, skeptics argue that spontaneous ignition isn't likely to be the reason. Another scientific explanation involves free-floating plasma orbs created when surface electricity is discharged into a solution. Still, these typically occur in controlled settings during experiments, and not naturally. We can carry on with ball lightning. It's a super rare thing, a glowing ball that shows up in the air. It likes to make an appearance close to the ground during thunderstorms, hanging out with regular lightning. It can be red, orange, yellow, white, or blue, and it's often accompanied by a hissing sound and a funky smell. This flashy sphere of light is a quick show. It lasts just a few seconds, zooming around, and then poof, it's gone, sometimes quietly, sometimes with a little pop. Ball lightning might seem like a troublemaker, but it's usually harmless. Sure, it's been known to burn or melt stuff on occasion, but it's not out to get us. Scientists aren't entirely sure why it happens or how it's related to regular lightning. People have been tossing around ideas like weird air or gas behavior, high-density plasma stuff, or even a vortex of glowing gases. Even microwave radiation trapped in a plasma bubble is on the list. But don't get it confused with bead lightning. That's a different one, more like a string of beads. And it happens when a bolt of lightning sticks around for a good chunk of a second. Shh! We're now at the Mapimi Silent Zone. It's this spot near this place in Mexico. The story goes that in this desert patch, you can't pick up any radio signals or talk to anyone. In July 1970, a rocket from Utah went off course and landed here. It was carrying some sort of cobalt. Authorities had to haul away tons of soil from the crash site. Now, thanks to the cleanup, the Silent Zone is wrapped up in myths. People talk about weird magnetic stuff, messing with radios, and about plants and critters going through mutations. Well, locals go with it, boosting tourism in the region. Alright, we can now talk a bit about the sun. Well, it's not just a big ball of fire. It's got an outer layer called the corona. Think of it as an invisible sun jacket made of gases. You usually can't see it because the sun is super bright. But there's a trick. During a total solar eclipse, when the moon slides between us and the sun, the corona shows up, all glowing and white. The corona is scorching hot, even hotter than the sun's surface, which is kinda weird. Scientists are on a mission to crack this heat mystery. They found something called heat bombs shooting from the sun into the corona, exploding and warming things up even more. But that might be just one piece of the puzzle. You see, the sun's surface is like a playground covered in magnetic fields. These magnetic fields create cool shapes on the sun, like loops and streamers. Special telescopes help us see these cool patterns up close. The corona stretches way out into space, and from there, it sends out the solar wind that moves through our solar system. Its particles are so speedy that they escape the sun's gravity. So, there's this cool spot called Kuala Sangalore Beach that you can only check out when the tide is low. The timing changes every day, and you can't get there when the tide is high. Most of the time, it's hiding under the sea, not even on the map. But when the tide's just right, bam, it pops up. Kind of like Malaysia's own version of Salar de Uyuni. People call it the mirror of the sky, because when it's not underwater, it turns into a giant reflection of the sky. An awesome spot for cool Instapics. Besides being a sweet travel spot, it's also home to a bunch of marine life, like sea and baby clams that live all over the sandy shores.
Living on our beautiful planet might seem safe, but only until you start thinking of all those dangers lurking just around the corner, or in the vast darkness of the cosmos. Let's see what may eventually lead to the end of planet Earth. With each new potential threat, it gets more and more terrifying. Consider yourself warned. First of all, let's talk about hypercane. This natural disaster can get really extreme. A hypercane is a theoretical hurricane of unsurpassed power. It would occur if the ocean became over a volcanic eruption could trigger it. In any case, these conditions would create a hurricane, which, unlike regular hurricanes, would stretch way beyond the lower stratosphere. The speed of such a storm would reach 500 miles per hour. The pressure inside the hypercane would be so low that it wouldn't let it wear out as quickly as other hurricanes. The hypercane could last for weeks on end. But the worst thing? It would likely damage or even destroy part of Earth's ozone layer, and the hole could be the size of the entire North American continent. Then we've got super destructive tornadoes. A tornado is a violently rotating column of air. It usually extends from a thunderstorm and is in contact with the ground. Inside a thundercloud, warm, humid air rises upward, and cool air falls down along with rain or hail. Such conditions can lead to the appearance of spinning air currents inside the cloud. Interestingly, these air currents start out horizontal, but at one point they can become vertical and drop down from the cloud, becoming a tornado. Some tornadoes are narrow, rope-like swirls, but others turn into wild funnels. Tornadoes are ranked with the help of the enhanced Fujita scale. A weak tornado normally lasts for a few minutes and doesn't move faster than 100 miles per hour. The next level is a strong tornado. Such whirlwinds can last for 20 minutes or so and have winds of up to 200 miles per hour. And then we can also have violent tornadoes. Those can last for more than an hour and move at a speed of between 200 and 300 miles per hour. On average, around 1,000 tornadoes occur in the USA every year. There's even a region that got named Tornado Alley. It's a 10-state area in the Midwest, but tornadoes can happen in any state. One of the most destructive natural disasters was the tri-state tornado in the USA. It was the world's longest-lasting single tornado that traveled 220 miles through Missouri, Illinois, and Indiana. At the same time, the average tornado's path is usually no longer than 5 miles. But what if one day, a tornado much bigger and way more powerful than any we've experienced before swiped through countries and continents? It would leave behind total destruction and devastation. And how about a supercell thunderstorm? It's the least common type of thunderstorm, but it's the most dangerous. It's likely to cause severe weather, damaging winds, very large hail, and even violent tornadoes. What makes supercells unique is a deep and persistent rotating updraft called a mesocyclone. Supercells can potentially last for hours and cause great havoc. An asteroid impact could end all forms of life on Earth too. If a space wanderer was large enough, it could cause widespread devastation, like it happened with the 9-mile-wide asteroid from 66 million years ago. It's rumored to have destroyed 3/4 of the planet's plant and animal species, including dinosaurs. Depending on the asteroid's size and the speed of its approach, the impact could lead to massive fires, tsunamis, and the eternal winter effect. It happens when the debris ejected into the atmosphere blocks sunlight and disrupts the global climate. Luckily, we'd probably notice such a large asteroid coming close to our planet with the help of our equipment long before the collision and would have enough time to get rid of this threat. It would be our very own sun that would bring our world to an end. Our star is a gigantic, constantly changing ball of molten gases. Every once in a while, it spews out bursts of energy, solar flares. They often go hand in hand with something called coronal mass ejections. Those are giant bubbles of ionized gas that can accelerate to incredible speeds. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with the temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. Scientists classify solar flares depending on how brightly they shine in X-rays. You aren't likely to notice the tiniest flares if you don't have special equipment. Medium solar flares lead to fleeting radio blackouts at the poles, but nothing too serious. It's X-class flares people should worry about. They cause the strongest and longest-lasting solar storms. Now, if you had gamma-ray vision, you'd be able to see immensely bright flashes. They occur every day, outshine everything around you, and then disappear again. Those flashes are gamma-ray bursts. One of them could wipe out Earth's atmosphere. The flash that might ruin our planet would most probably be born in a faraway galaxy during a merge of two collapsing stars. It would be immensely powerful and super bright. Still 1,000 light-years from Earth, it'd already shine as bright as the sun. Our planet's atmosphere would try to protect us, but its natural shield wouldn't last. The radiation would be so powerful that it would literally cook the atmosphere. It would create nitrogen oxides that would destroy the ozone layer. Without this layer, ultraviolet rays coming from the sun would be hitting Earth's surface at full force. They would wipe out tiny plankton in the ocean. But these plankton produce from 50 to 70% of all oxygen in the world. So, with their disappearance, there would be a severe lack of oxygen, which would lead to the disappearance of life on the planet. In the end, the heat and ultraviolet light coming from the sun would turn the planet into a huge chunk of rock. And what if we came across a wandering black hole? You might know that a black hole is a region in space where gravity is so powerful that not even light can escape its clutches. Luckily, the nearest to us black hole is 1,500 light-years away. It seems that we have nothing to worry about until we learn about wandering black holes. Now, things definitely get way creepier. If such a black hole entered the solar system, Earth would be doomed. We wouldn't stand a chance against this space monster. In 2020, 13 wandering black holes were spotted not so far away from our planet. But not far away in space terms means around 1 billion light-years away, so we've got some time left. Plus, the possibility of such a disaster is very, very low. One day, a rogue planet might push Earth out of the habitable zone and into an extreme orbit farther from the sun. Then, the climate all over the planet would start getting colder and colder. Don't forget that the farther our planet is from the sun, the weaker the star's gravitational pull on our planet is. In the end, our beautiful Earth would get too far away from its main source of light and heat. It would turn into a lifeless piece of rock covered with a thick layer of ice. Or the sun might expand and turn into a red giant. If it happened, it would change the entire habitable zone of our solar system. The disaster would start with our star running out of hydrogen in its core. This would trigger a chain of reactions, which would eventually lead to the core of the Sun heating up and getting denser. As a result, the Sun would get way larger than it is now. During this transformation, the Sun would swallow Venus, Mercury, and Earth.